Hey guys, welcome. So part 21 of our fun challenging integral video series, and this is not so challenging at the start, but it's pretty fun and a tad bit challenging towards the end. So the task is to show that this definite integral has the value pi over 16. Okay, now first we need to complete the square on the denominator of the integrand. And I'm not going to teach you how to complete the square because that's a skill you should have if you're watching an advanced integral video. But yeah, if you complete the square correctly, what you'll find is that the quadratic denominator and the integrand is the same as this here. So then that means that we could rewrite our given integral to look like this. Yeah? Okay, cool. Now, from here, we make the substitution that u be equal to x minus a half. That means then that du is equal to simply dx, right? Okay, cool. And then the upper and lower limits, this guy, the 3.5 and the 1, the upper and lower limits will have to be based on our substitution 3 and 1/2 respectively. So the 3.5 will turn into a 3, and then the 1 will turn into a 1/2, right? Okay, cool. Now that means that we're ready to translate our integral to be about u. And so that's this here. And if we factor out a 4 in the denominator and then therefore write a 1/4 in front of the integral, then this is the integral that we have, which is the same as this here. And this is pretty easy to recognize as being tan inverse u, right? Okay, so we know that our answer is 1/4 tan inverse u evaluated at 3 and then a half. And so that would be this here. And since we called our original integral I, it means that I is equal to 1/4 tan inverse 3 minus 1/4 tan inverse a half. Okay, where to from here? Well, we need to somehow show that this here, I, is equal to pi over 16. So to do that, let's consider 4 times I, because then that means we could get rid of this quarter and this quarter here. So 4 times I is tan inverse of 3 minus tan inverse of 1/2. So let's take note of this and then make some space, because we definitely need the space. So again, 4 times I is equal to tan inverse of 3 minus tan inverse of a half. Okay, so from here, as I said, we need the space. So delete, and then recall that tan of alpha minus beta has this formula on the right hand side of the equal sign. Okay, so if we take alpha to be tan inverse of 3 and beta to be tan inverse of 1/2, then we can write tan of 4i, that is tan of alpha minus beta, like this. Remember, this here, tan inverse of 3 minus tan inverse of 1/2 is 4 times I. So that's what I meant by tan of 4 times I, or tan of 4i. So tan of 4i is equal to this here. And this simplifies very nicely because tan and tan inverse cancel each other. And so this here, tan of tan inverse of 3 is just 3. And so doing similar canceling, we see that this is what we've got, which reduces very nicely to 1. So we see that tan of 4i is equal to 1. Got it. So since tan of 4i is equal to 1, that means 4i is equal to tan inverse of 1, right? So 4i is equal to tan inverse of 1, but tan inverse of 1 is pi over 4. And so 4i is equal to pi over 4, from which it immediately follows that I is equal to pi over 16. Yeah? All right, cool. I hope you enjoyed this and keep watching. Take care.